So my name's Sumner, and my talk is all about the big NHS computer. The quote there is from the Prime Minister at the time. This was back in 2001, I believe, and he was talking about the possibilities of introducing more electronic transfer of communication to the NHS. And so what I'm going to try and talk to you about today, hang on, if I get this working correctly. There you go. I'm going to try and tell the story about what happened after that. Now, it's a 15-year story, so it will be a bit of a summary. I'm going to try and squeeze it into 20 minutes, okay? Most of the story is pretty depressing. You know, it's a sort of, as a movie, it'd be a disaster movie. It'd be like the Poseidon Adventure. It'd be like the Titanic with Celine Dion singing all the way through. You know, it's a pretty ugly story that we've got to tell. But fortunately, towards the end of it, there's some nicer things coming out of it. So I'm going to try and focus on the nice things at the end, because most of the rest of it is pretty hard going. And at the end, I'm going to try and rant and preach a bit about really not so much about the bad things that happened, but some of the good things that are happening now and kind of what we've learned from that coming out of the other end. In this talk, I'm going to be speaking as me. I don't represent the NHS here or anything like that. So, you know, this isn't officially the government talking or anything like that. And if you're interested in the slides, they're all there up on GitHub pages at the moment. So, yeah, many of you may know that after that talk, most of the next 15 years was about this big project in the NHS to introduce electronic records, and it didn't go very well. And how do we know it didn't go very well? Well, we can go to Wikipedia, and Wikipedia has a page called the List of Failed and Over-Budget Custom Software Projects. If you go to that page, there is a subheading called Permanent Failures, yeah? If you look under permanent failures and look for the biggest fucking number you can find, you will find the project, yeah? And that big number that you may not be able to see from the back is £12 billion, okay? So it failed, and it failed spectacularly. And, how do you spend £12 billion on a computer system? You may be worried that all the government does is goes and sends out checks of £12 billion to suppliers and waits for nothing to come back. Okay? Well, it's a bit more sophisticated than that, because actually the government's got no money to spend on IT right now in this year, and never has had in any year. But what it's always got, it's got the promise of future tax revenue to spend in future years. So what the government does, it goes out to suppliers and says, we can't afford this IT system. Can you build it for us anyway? But make sure it's like this. And when it turns up like this, we'll guarantee we'll pay you for many years in the future. Yeah. So rather than giving them a load of money and waiting for nothing to come back, what we in effect do is wait for nothing to come back and then give them a load of money, okay? Because by the time we get to the stage where it's delivered, it's really uncertain about what's been delivered, whether it is A, what we want, and B, what we ask for, and there's lots of confusion around that, but everyone wants a system by then because we've been waiting a while, and the suppliers invested a lot of money and they wanted to be paid, so the revenue tap tends to get turned on. So, given that we know that's the case, and we knew that was the case back in 2003, how do we get into this mess? Well, actually, one of the reasons was the guy that was at the top of the project at the time, he realized that this was a problem, and he felt he knew the answer, okay? And he felt the problem in the past was that government was weak. It didn't manage supplies in a strong way. And he wasn't weak, he was a bastard, yeah? And what he was going to do, he was going to manage suppliers, and he described it as treating them like a pack of huskies, yeah? And when one of them fails, he would shoot them, yeah, as a lesson to the others and feed them to the others to make them stronger. And that was going to make things go better. So they set off with their huskies, and the first husky went off really fast, but was a bit erratic. So he asked why the other huskies weren't doing anything, and they said, well, the first husky may be going fast, but it's erratic, and that's putting us off, so would you shoot the first husky? So he shot the first husky on the behalf of the others, and then the second husky then wasn't delivering even after he shot the first husky. So he threatened to shoot the second husky, and the second husky just ran off rather than waiting to be shot. He then decided that the third husky needed shooting, but the third husky hired a lawyer, yeah, and the lawyer said, you can't shoot me, I'm going to see you in court. now we're in a bit of problem because the fourth husky is also the first husky, and you've already sort of shot them, so you've got to try and pretend that that's working. And then the fifth husky really starts failing, but you can't afford to deal with the lawyers of the third husky and the fifth husky at the same time, so you then have to start to pretend that's working. Okay, so this aggressive management of suppliers did not have a different outcome. And so this is something I wrote in a document many years later describing a potential different approach. We got in the position whereby shooting huskies wasn't going to do us any good anymore. So this whole program involved many, many, many different projects, okay? And a lot of them failed for all kinds of different reasons and this kind of stuff. But I'm going to tell you just about one of them, and this is a project called The Spine. And the main reason I'm going to tell you about The Spine is the one that involves me the most, you know, and I've got the microphone and I've got the stage, so, you know, it's the thing I'm most interested in. And in particular, I'm going to talk to you about a part of the spine which is known as the core spine. And the idea behind the core spine is we're going to have all these other different systems that were going to be developed around the country, but we needed something that was going to communicate between those systems. They wanted somewhere central to go and store their records, somewhere central to pass messages between. And the records we're going to store care records, and we're going to store clerical records, and we're going to store prescriptions, and we're going to update the state of prescriptions, and we're going to communicate between different systems, we're going to forward messages, we're going to transform messages, we're going to do all of that kind of stuff. But it needs to be done on a grand scale, yeah, because we've got all these systems around the NHS communicating with it, and the NHS is big. It is potentially the third biggest employer in the world behind the Chinese Army and the Indian Railway. You know, it is a big old place. So we needed a spine, okay? And just like all the other projects, Spine didn't necessarily go smoothly. And so this is a headline from 2006 after Spine just put out a release. It's a headline from The Guardian at the time. So kind of how did this work with Spine? So back in early December 2003, we had contracts award to BT, or a part of BT called Syntegra, and I was working for that company at the time, and I was really excited because I got to work on this big, massive project. In July 2004, we went live. The requirements had turned up sometime around about May, June 2004, so you may be thinking for a big system right now that things are moving forward at a fairly fast pace. October 2004, we're fairly tired of the first release. We wouldn't mind another one coming along. February 2005, we wouldn't mind another release coming along. February 2005, one of the main features of that release was driven by one of the other suppliers, one of the other Huskies, that insisted the only thing that was holding up delivery was the lack of this feature. They didn't actually use that feature until May 2010. Okay, so that shows how the Husky game was influencing timescales going on. In March 2005, BT, as the Husky, were rather fatally wounded by the supplier at that stage, and hundreds of consultants and external managers descended on the program to fix it. They came up with lots of ideas. Many of them weren't very good. Okay, but they came up with one idea that was genuinely good and seemed to work, which was to slow down, yeah, because actually that was pretty fucking helpful because it had been fairly hectic up until this point. I wasn't particularly happy with all the other ideas, and I sort of left at this stage. They then moved on, and they waited until December 2005 before having another major release, and then that led to that headline from the previous slide. That hasn't gone very well. So what's the answer to that? Well, we'll get much slower. And so they did get much slower. And what happened then is that there was a general perception created, both within BT as a supplier and within the NHS as a customer, that Spine was becoming a success. And we know what BT think about it because it's still on their website. You can go Google for BT NHS case study Spine, and they've got a whole set of case study there with lots of quotes. So it says, yeah, we're doing all this great stuff, 1.3 million systems, loads of different applications, that's all wonderful. And they describe what's amazing about it, one of the most amazing things about it, and this was written, I believe, in about 2008 or 2009, is that we've consumed over 15,000 man-years to date. So this has been going for about 6 to 7 years at this stage. So yes, that is over 2,000 people are now working on this delivery of this IT system. There are over 3,000 servers serving up the solution. And they've decided that how they're managing all of this is now world-class. It's now an internationally recognized standard how to do things. And what's the consequences of that is, well, by this stage, Spine could do a release, and it could release fairly reliably, yeah? Not entirely reliably, fairly reliably, but a release cost about £30 million in transition costs alone. It costs about £50 million each year just to keep the line on. About 50% of the original business case has been met, so it's not a total failure like some of the other systems. And the system is stable, but just keep away from it if you could, and it will stay very available. And it was highly available at this stage, but it was expensive. However, the general perception was within the NHS as a customer, with BT as a supplier, that really was the cost of doing things like this. You know, you needed 2,000 people. To manage 2,000 people, you needed a completely different approach to managing the program. You needed 3,000 servers. It's going to cost you a lot of money. So that's where we were. But the thing that happened then is by now I'd moved over to, and I was now working on the NHS side, and I got invited into a little program team that was looking at how we replace Spine, because it was a 10-year contract, and now that contract is coming to end. We need to do something about it. And there was a sense of uneasy inevitability, what doing something about it meant, because if the original has cost you nearly £1 billion, which is where Spine was at by this stage, you're sort of in a position whereby you need to go out, you have nothing else to anchor to other than the fact that it costs £1 billion. So you talk to the sort of people who can manage a £1 billion programme. They put you in touch with their £1 billion programme teams, and they decide it's probably going to cost about £1 billion. And, but unfortunately, it will need a lot of capital up front, which you don't have, yeah? So as long as you can sort of spread out some payments over the next 10 years of taxpayer revenue, we'll be more than happy to do it for you. And it doesn't help, there's an uneasy feeling that really what was going to happen as a consequence was inevitable. And at the time, I started to pose the question about what if we think differently, because after I'd finished my work on Spine in sort of 2005, I'd spent a lot of time thinking about what was happening on the programme, and I started reading about other approaches to addressing programmes. So I started reading about the Toyota production system and this kind of stuff, and at that stage, a lot of people started talking about agile development. I started reading about other technical solutions, so I started looking at how people had used Erlang to make the telecoms and communication infrastructure really reliable. I started looking at how Google and Amazon were scaling out and looking at those lessons. And I thought that there are better answers to this problem than this one we had. This 3,000 servers, this 15,000 man years, this world-class new way of managing programs wasn't the right way of doing it. So I put forward a hypothesis, and that hypothesis was we could just put a team together and we could just do it, and it'd be a lot cheaper, okay? Unfortunately, no one agreed with me, okay? And that was a bit of a disappointing moment. And I thought, well, what do we do about that? Because it's really, really hard to persuade people that are very much committed this way forward. That's the right thing to do. And I sort of thought, well, probably the best thing to do is just to start doing it, yeah, and then we'll ask for forgiveness later. So we thought, well, no one's going to notice if there's just two of us working on it, so two of us started. We started writing the code, we started developing part of the system, we started volume testing it, we started sharing the results. And then one or two people started believing us, yeah. So we got 3 more people along, and they expanded the team. We carried on building bits of the solution. We carried on testing it. We carried on volume testing. We carried on demonstrating how it did. And a few more people believed us. And that gave us permission. Or then we sort of said, right, we can go out and talk to some suppliers. And we looked at some technology stacks that were based on these lessons that we'd learned. There were technology that was coming out of these large-scale internet companies like Google and Amazon, and people copying their ideas and implementing it. And one of the big ones is REAC, who Basho are sponsoring tonight. So we picked up that tech stack and we started evolving it. And then we got permission to go out and get a delivery partner. And rather than going out to a big company, we managed to go to a small and medium enterprise, which was a software company in Leeds called BGSS. And they came on board as a delivery partner. And we explained how we wanted to work. And they explained how they wanted to work. And we agreed a compromise way forward. And, they had to compromise on some of their ideals. We had to compromise on some of our ways of working. Like, I had to stop writing such shit code. And then started using better standards and that kind of stuff. But we kept on moving forward. And the consequences of this is that it became more and more real, and a few more people started to believe us. And it then became the actual way forward of how we were going to replace spine. And within the NHS, it made people really angry, yeah? Because people thought this was incredibly irresponsible. How dare we go out and put the NHS at risk like this? How dare we replace a £1 billion programme with something thrown together with a team of 20 people? It was seen, and those people that weren't angry were genuinely scared about what might happen. Well, could we affect the good work that had been put into spine? Because after all, spine was still a highly available system. And what if it didn't become available? What if all those systems that depend on it stopped working? What would happen? And we kept having to prove those people. And it was a battle. For the last year was really a battle about proving that we were ready to go live and allowing people to transfer the data to us, that kind of stuff. But it went live. And in August 2014, this system that was built by this group of 20 people replaced this £1 billion programme. So, what did it cost? Well, to get to 1 year's service from go live, it cost 100 man years, yeah? Not 15,000 man years. It runs on just 100 one-rack unit commodity servers split across 2 data centres. Our release costs are currently less than 1,000th of what they were previously. We now release major functional releases every week, every month, and weekly releases on top of that. We have a 90% reduction in operating costs. We have a total team of just about 30 people that are looking after the spine core at the moment, but as well as looking after spine core, they're also dealing with a backlog of changes, and we're dealing with about £10 million of change each year. It's a nearly like-for-like functional equivalent. We did drop some of the functionality that wasn't being used. We've achieved 5 nines availability since we went live, so the thing that people were afraid of didn't happen. We support about 300 message interactions and 5 user interfaces. We deal with just short of 40 million messages a day at the moment. And a message for us is about sort of 20 kilobytes of XML that needs to be sort of transformed and processed. Some of them more complex than others. Some are like, release my next 25 prescriptions and change the status of them all and that kind of stuff. Some of them are just fetch a record for me and transform it and that kind of stuff. But it's about 40 million messages a day, about 2,000 messages a second at peak. It provides access to we store about 1.5 billion records and documents within our database. And it is quite performant as well. So we actually calculate after we went live that every day the NHS was spending 800 working days less waiting for a response from spine than what it was spending previously. So it's made quite a positive difference. So that's kind of the story of how we've gone through some bad times. And certainly on one project, we've emerged with a new story, a better story. And there are other parts of spine as well as spine core. There's an identity service and there's a secondary usage service. And one of those projects has also got a story of moving forward positively. And hopefully the other one will have a positive story in the future. So as an organisation, it feels like now we're beginning to do things better. So here's my kind of rant a bit about what we've learned and this kind of stuff. So when I first put forward the proposal, one of the big points that I try to make was that in the past, government has always tried to predict the future, and we're human beings, so we think that we can predict the future. We suffer from all these cognitive biases that make us think that we're experts and good predictors of the future, that we predicted the future well in the past. We suffer from a hindsight bias that always makes the past look really obvious once we get to now. So we're always convincing ourselves that we can predict the future. And obviously, in government, that's even worse because we've got to pay for over a long period for these large capital expenditures we want in this project. So, we've got to predict 10 years into the future, not just next month into the future, that far away. And on always these projects failed, and the answer is always, well, next time we'll invest more in predictions, yeah? We'll hire more consultants at the start, we'll have more techno-economic models, we'll build more spreadsheets, we'll have more gates and all this kind of stuff. And the proposal we put forward at the start of this is that we want to take the opposite approach. We're going to get ready for our predictions to fail, yeah? we're going to invest as little as possible in predictions, and we're going to get ready to be able to modify and progress and this kind of stuff. And that's what we're continuously trying to do. And it's kind of, for us, it's a hard mental state getting to, because we've got to continuously fight against our cognitive biases to make this work. But ultimately, predictions are hard. And so we still make predictions, because we have to put a stake in the ground, but we invest less in predictions and get ready to change. Oops. So the other thing as well is about the people that we use and this kind of stuff. So this is a quote from Fred Brooks, who wrote The Mythical Man Month. He also wrote a paper called No Silver Bullet in 1986, and he was talking about the need for good system designers. And so we think that's really important. Now, Fred Brooks probably thought about systems designers in terms of people that were doing big architecture up front and this kind of stuff. We want to do system design continuously. And when we talk about system design, we're always thinking about our spine system, not in terms of the software or the hardware or the people or the service model or this kind of stuff. We want to try and think about all of that together. So, we build it and we run it because we want to think about the system as a whole, the people, the processes, the technology that make spine work. And we want as many as people that work on spine thinking about the system as a whole. So, we don't want to recruit people who are developers or want to be testers and this kind of stuff. We want to recruit people who are going to be system designers, but are also going to work on development and going to work on tests, going to work on support and that kind of thing, but are going to be able to think about the system as a whole. And so that's a big thing for us moving forward. We don't really want to scale out our team. We want to make more of our team systems thinkers and make our team more efficient as a consequence. Uniformity of system behavior, that's really important to us. Although one of our outcomes is we made spine more performance doesn't really matter to us or to the NHS that much. What really matters is consistent performance. And also what matters to us is to get high availability, is that we want to get rid of edge cases which have oddball performance scenarios. Because oddball performance scenarios, when you start adding two events together with oddball performance scenarios, are often going to lead to availability problems. So we spend a lot of time optimizing performance, and often, upfront optimizing performance is considered premature optimization. But we're never trying to optimize the mean. We're never trying to make the average faster. What we're trying to do is find the edge cases and smooth them down so that we've reduced the variance in performance. That's been really important to us in the principles of how we try and design the system. And REAC as well has been very important in helping us to achieve that. Because although it's not the fastest database, it is a very available database and gives us very reliable guarantees about how it will perform. Getting away from failure. So failure is going to occur, okay? And when we worked on Spine 1 back in those days, the way we were going to get high availability was to reduce the mean time between failure. Okay, so there was a lot of effort putting on buying systems that hardly ever fail. And then when they still did fail, we worked on the mean time to repair. So it was always about getting people with 1 hour response times and this kind of stuff. We don't care about that. We have none of our kit on anything but a next business day support contract. Everything is about the mean time to recover. All we want, if we've got a problem in our system, is to move service away from where the problem exists to where the problem doesn't exist, okay? So we're very keen on making sure that connectivity between our systems, we're not trying to maintain state in a consistent way a lot of the times. We're always trying to be eventually consistent and asynchronously replicate, because it makes it more likely that a problem in one area hasn't affected a problem in another area. When we choose products, quite often in the enterprise space, or historically certainly where I've worked, there's been a tendency to buy magic boxes. And magic boxes are things that come with magicians. And magicians are those people with expense accounts that are really good at misdirection. Okay? And what they don't want you to do is they don't want you to look inside of the magic box. They want you to believe it's magic, yeah? It does everything you want it to do right now. And if you don't want it to do that, there's a roadmap, yeah? And it will do everything you ever want it to do in the roadmap. okay? But don't look inside the box, yeah? That needs to be closed from you. We wanted to have products that were open, yeah? That were simple building blocks that we could do many things with. So we chose products like React and Redis, not because they did a lot of things, but because they did simple things that we could exploit, and we would understand what they were doing, and they were very open about how they did it. They were very open about the problems in it. So going back to the early days of Spine 1, when it suffered from all kinds of problems of stability and this kind of stuff, which is in part due to the fact that how much we were rushing and this kind of stuff, but 60% of our downtime at least was down to one Oracle bug, yeah? And, you know, no one knew about this Oracle bug, even though it could potentially affect anyone who was running Oracle RAC, because they were a closed support system. They kept everything inside of the box. And we wanted to move away from magic boxes and have simple open building blocks that we could So a lot of our products are open source, but open source was what we were concerned about. What we were concerned about was openness about the organizations that built the boxes and how they behaved. So there's this sort of joke about what the two hard problems in computers are. And we really focus on the first problem, cache invalidation, because that is becoming an increasingly hard problem. You know, because if we're trying to do distributed systems, we want to try and make sure we know in memory, close to the customer, what the current version of an object is. Yeah, and so when that changes, we get this cache invalidation problem, and it's all over the place. It's all over the place if you're trying to run single systems, multi-core. It's all over the place if you're trying to run distributed systems. This is the hard problem, and this is what we spend a lot of time focusing on our effort on resolving from a technology perspective. And the kind of final big lesson for us that we've learned, and for us I think is probably the most important one for us going forward. So certainly the most important one for us at the start was the whole thing about predictions and about getting away from trying to predict the future and relying on those predictions for the future. This is the case of one we've probably taken away with now, is that going into this project, we had an idea about what we meant about agile, and we had an idea about certain constraints that we were facing and how we were going to deal with those constraints. And we were dipping into this agile toolbox to go and fix these problems. And we came up with our own process about how we're going to deliver that suited us. Yeah, because we had this mission that we wanted to build a really highly available system. Yeah, and that was our primary motive. We want a highly available system with a low total cost of ownership. Yeah, and so we built a process to do that. Okay, and that worked for us. Okay, that might not necessarily work for someone else. Yeah, and nowadays, as I go around different organizations, I see a lot of people copying other organizations. So just as the Toyota production got copied by American motor manufacturers without actually achieving the same efficiency, I see the same sort of organizations that go and say, right, well, we'll take the manuals from Spotify and we'll scrub out Spotify and we'll put our brand name on the top, and well, you know, we're agile as well. And I walk around my own organization, I see people, and they all want to copy the easy stuff. So we'll do our meetings in the morning standing up, and we'll write our tasks on cards, and yes, we're agile too, and we know all about this. And it's also a big problem in government right now, because whilst we were doing our agile project, there was another organisation in government called gov.uk, and they were doing their agile projects, and they had their own mission. They had a mission that's formed around this idea of being sort of the web, not behind the web. So they're very much into having digital-led services, and you know. And they developed an agile process for that, which is great, and it's worked very well for them. But now what we've got in government, there's a thing called government digital services, which is saying, oh, well, let's copy that method and force that on every project. And as long as we don't interact with the people and hear what they've got to say about it and just insist that the method's right, then we can make everyone else agile just like us. And I think this is one of the increasing problems that I'm seeing now. You know, Toyota, when you look at the progress of how they moved Toyota production system through Toyota as an organization, it took decades to make that happen. It took decades to get that Kaizen, that learning process through everyone and evolve things that worked in everyone's different contexts. And that's what we're seeing now is an important lesson to learn, that, you know, we did some stuff that was very successful for us. We did it using distributed systems. We did it using lean and agile processes. But copying us doesn't make other projects successful, and replicating that isn't going to make our future projects successful. We have to keep learning the same way that we learned to build that first system. So, firstly, main conclusion, government IT's got a fairly bad reputation. Go to that Wikipedia page, see all the government projects, see all the Union Jacks, realise it's mainly our government, yeah. So it's got a bad reputation, and working in government IT has not been a nice place to work for a long time, yeah, because either you're stuck with very little prestige for what you're doing, or ultimately you're dealing remotely with a supply you have very little control over. But actually now in pockets of government, there's some really interesting IT work going on, and actually we are achieving things, because in government we have some fairly hard technical problems. Building a solution for the NHS with its 750,000 employees is a fairly hard task. So we do have interesting technical challenges, and we are beginning to address them in an interesting way. Radical change is possible in an organisation. So, when I first started in the Health and Social Care Information Centre, which is what it's now called, it was then called Connecting for Health, we did no development work in that organisation. Yeah, and I did some development work, and I was pulled in and admonished for it. We now take our crown jewel programs and do them through in-house development in partnership with third parties. So we have radically changed that organisation, and we didn't do it by getting permission from the top. We did it by proving that it worked, and that allowed us to make the difference. So, blindly following what happened before doesn't necessarily lead to the best results, and you can change things. The other thing I say as well as a general point is that history is rich and full of answers. So most of my learning that I've got comes from reading things that were written by W. Edwards Deming in the 50s and written by Taiichi Ohno in the 70s, or by Fred Brooks in the 70s and the 80s. Most of the tech things that are going on in Google and Amazon now are coming from papers written by Leslie Lamport and other people like that 10, 20, 30 years ago. History is very rich, and it's full of a lot of answers that we can use. So although now we're moving forward and we're in this digital generation and it's all new and it's all different and this kind of stuff, I don't think we should ignore the fact there's actually a lot of lessons to be learned from the past. So that's my rant bit over, and that's my story bit over.